Professor Jim Schultz here from my Finance 512 class. As promised, I wanted to get this duration video done for a semi-annual coupon paying bond. And so let's go ahead and get right into it. This is one of the problems I just recently sent out. And you have a 4-year bond that pays a 6.5% semi-annual coupon, and the yield to maturity is 7.45%. Alright, so the general structure of the table will be exactly the same, with the same 5 columns: time until maturity, cash flow, present value of those cash flows, the weight of that cash flow relative to the total amount of cash flows, which I'll scroll down in a second, and then the weight times the time, or the weighted time. Now, one thing you have to note that's a little different: in the time until maturity, remember, this needs to be represented in years, and so since you have payments occurring every 6 months, you need to move in half-year increments. So that is why you see 0.5, 1, 1.5, and so on, all the way down to 4, because there's 4 years total, and so there's 8 6-month periods in 4 years. The next thing, this cash flow column, this is something you should remember from 311, 680, your earlier studies. A 6.5% semi-annual coupon, that is an annual number to get you to the annual coupon payment, which obviously is just the coupon rate times the par value. So that's $65 a year. So if it's $65 a year, then it must be $32.50 every 6 months. So that is where you get these cash flows that simply repeat until the end. You have to tack on the $1,000 principal payment, or par value. And then to find the present value of those cash flows, you just use the basic present value formula, which is PV equals future value divided by 1 plus I raised to the n. So we're just repeating that formula over and over again. One thing to note, though, and this is probably where most students would make mistakes on this problem, your yield to maturity is 7.45%. That is also an annual number. Since your cash flows are semi-annually, you need to be discounting at a semi-annual rate. So that is why you see 1.03725 in the denominator, because 3.725% is half of 7.45%, right? And so 1 plus that number as a decimal is 1.03725. All right, and I got some scribbles down here, but it's 1.03725 in parentheses in the denominator all the way down. And you're simply changing your exponent as you move further in time, right? Your exponent here, since this is a semi-annual rate, this is the number of semi-annual periods you have to move back. So when you know, like take this second cash flow, for example. This second cash flow occurs at the 1-year mark, right? But to bring something back from the 1-year mark to now requires 2 semi-annual periods of discounting, right? And so that is why that is 2, 3, 4, and so on. And so that's how you get these present value, all these cash flows. And then when you scroll down, you see, and obviously the final one is much larger than the preceding ones because of the par value that's included. When you add up the sum, I get that annoying message box. My computer is not that awesome, so it can't handle too much going on at once. When you take the sum of the present value of all these cash flows, you obviously get $967.65, and this is, again, the bond's price. And so then when you're looking for the weight of each cash flow, you simply divide the present value of that cash flow by the price, and that gives you the weights. The exact same, from this point forward, it's exactly the same. It's identical to how we did it in class. So that's how you find all the weights, and then the weighted time is simply your weight column times your time until maturity column. So this is going to be a half times 0.0324, you get 0.0162, and so on down the line. And then when you sum up your final column, you get 3.58 years as your duration. So hopefully this was helpful for you guys.